Day 488 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 3027. Find the number of ways to place people to. The difficulty level is hard, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, comment, subscribe, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given a 2D array points of size n times 2 representing integer coordinates of some points on a 2D plane where points of I is equal to xi, yi. We define the right direction as a positive x-axis increasing x coordinate and the left direction as a negative x-axis decreasing x coordinate. Similarly, we define the up direction as positive y-axis increasing y-coordinate and down direction as a negative y-axis or decreasing y-coordinate. You have to place n people, including Alice and Bob, at these points such that there is exactly one person at every point. Alice wants to be alone with Bob, so Alice will build a rectangular fence with with Alice's position at the upper left corner and Bob's position at the lower right corner of the fence. Note that the fence might not enclose any area, i.e., it can be a line. If any person other than Alice and Bob is either inside the fence or on the fence, Alice will be sad. Return the number of pairs of points where you can place Alice and Bob such that Alice does not become sad on building the fence. It says, note that Alice can only build a fence with Alice's position as the upper left corner and Bob's position as the lower right corner. For example, Alice cannot build either of the fences in the pictures below with four corners at 1, 1, 1, 3, 3, 1, and 3, 3 because with Alice at 3, 3 and Bob at 1, 1, Alice's position is not the upper left corner and Bob's position is not the lower right corner of the fence. With Alice at 1, 3 and Bob at 1, 1, Bob's position is not the lower right corner of the fence. So let's just go ahead and take a look at this note right here. Let me zoom in for y'all so we can see it better. So this is just an example of what we cannot do, right? We need Alice to be at the upper left corner. Sorry, y'all. We need Alice to be at the upper left corner, right? It says right here, Alice's position at the upper left corner and Bob's position at the lower right corner. Boom. So in these pictures, we have Alice at the upper right corner, which is not what we want. And we have Bob at the lower left corner, which is not what we want. Alice should be here at the upper left corner and Bob should be here at the lower right corner. Similarly, in this picture right here, we have Alice where she's supposed to be at the upper left corner, but Bob is not where he's supposed to be at the lower right corner. Bob is right here at 1, 1 when he should be over here at 3, 1. So now that we understand, or excuse me, we don't understand the question yet. Let's go ahead and take a look at these examples to make sure that we understand the question before we get to moving to the solution. So in example 1, we have this picture right here. Example 1, we have our input points equals a 2D array of integers 1, 1, 2, 2, and 3, 3. Our output is 0. The explanation says there is no way to place Alice and Bob such that Alice can build a fence with Alice's position as the upper left corner and Bob's position at the lower right corner. Hence, we return 0. So in this picture with these points right here, as you can see, these points all go up and to the right. And since every time the point goes up and to the right, then you can see that there's no way for us to put Alice up and to the left and have Bob at the lower right. Right? Because in order for Alice to be at the upper left corner, we would need a point to be at the upper left corner. But all of these points go up and to the right. So there is no point that we can create that will be at the upper left corner of the rest of the points, right? So we return 0. So let's take a look at example 2 where there is 2 different options we can choose. So in example 1, we have our input points equals a 2D array of integers. First one being 6, 2, then 4, 4, then 2, 6. This time our output is 2. Boom, let me see if I can zoom in a little bit more for y'all. Let me see. Oh, well, I don't know. It's not working. There we go. Boom. So now The explanation says there are two ways to place Alice and Bob such that Alice will not be sad. Place Alice at 4-4 and Bob at 6-2. So that's in this example right here. We have 4-4 right here, which is index 1, and 6-2 right here, which is index 0. We could place Alice right here at 4-4 and Bob right here at 6-2, and that fits the requirement. We have Alice at the upper right, Alice at the upper left corner. We have Bob at the lower right corner. And then the third person is all the way over here, far away from the fence, so Alice is not sad. Similarly to the second option, we could place Alice at 2-6 and Bob at 4-4. So then this option, we could place Alice up here. We could place Bob right here. Then the third person, once again, is all the way over here, so Alice is not sad while she's behind the fence, and these fit our requirements. Once again, Bob's in the lower right corner, Alice is in the upper left corner. Boom, so it works. Now this is an example right here where it doesn't work. So our output is 2. These are our two choices. These are our two outputs that we can choose from right here, which place Alice at 4-4 and Bob at 6-2, or place Alice at 2-6 and Bob at 4-4. Now, this is an example right here where it doesn't work, right? Because it says right here, you cannot place Alice at 2-6 and Bob at 6-2 because the person at 4-4 will be inside the fence. So remember up here, it says if any person other than Alice and Bob is either inside the fence or on the fence, Alice will become sad, and we want to return the number of pairs where you can place Alice and Bob such that Alice does not become sad on building the fence. So in this case, as you can see, Alice will be sad because there is a person inside the fence. That's not what she wants. She just wants Alice and Bob, herself and Bob. She doesn't want anybody else in the fence, on the fence, or anything like that. And in this case, there's somebody inside the fence, which will make Alice sad, so we cannot include this in our output. Therefore, we only have these two options to choose from, so our output is 2 because these two options satisfy the requirements that we are looking for. So let's go ahead and take a look at example 3, where they might try to throw a trick question our way where it's just a line. Remember, it says up here that, let me see. Where does it say? Oh, right here. Note that the fence might not enclose any area, i.e. it can be a line. So example 3 is an example of where it will be a line, right? So in example 3, we have our input points equals a 2D array of integers. First array being 3, 1, then 1, 3, then 1, 1. This time the output is 2. Explanation says there are two ways to place Alice and Bob such that Alice will not be sad. We can place Alice at 1, 1 and Bob at 3, 1, and we can place Alice at 1, 3 and Bob at 1, 1. So that's these two examples right here, once again with the line. So this right here, place Alice at 1, 1 and Bob at 3, 1. So we could take this 1, 1 at index 2 and this 3, 1 at index 0, and that's going to create this straight line. And then Alice will be right here on the left, Bob will be right here on the right. The third person, or the third wheel, you can say, is all the way up here, which is not on the line. So that's good. That fits our requirements. Also, with this example right here, where we place Alice at 1, 3 and Bob at 1, 1, so we can place Alice here and Bob here, right? Alice will be up here and Bob will be right here. Once again, the third wheel is nowhere near the line. It's not on the line. It's not touching the line. So this fits our requirement as well. Now, it says right here, you cannot place Alice at 1, 3 and Bob at 3, 1 because the person at 1, 1 will be on the fence. Note that it does not matter if the fence encloses any area. The first and second fences in the image are valid. So right here, this isn't going to work. If we put Alice here at 1, 3 and we put Bob here at 3, 1, that's not going to work, because when we draw our fence and we make our fence, there's a person right here at 1, 1, which is on the fence, and that's not what we want. Alice will be sad because there's a third wheel on the fence, and that's not what we're looking for. So this does not fit our requirements, so we cannot include this in our output. We can only include these two in our output, and since there's two different options, we return our output of 2. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution, y'all. Now, the first thing we're going to do is we're going to sort the points by the x coordinates in ascending order. So if x is the same, then we're going to sort by the y coordinate in descending order. And this is going to ensure that for the same x, a higher y value comes first. So we're going to come right here inside the function. We're going to declare a variable called sorted x equal points dot sorted. We're going to open up the brackets and we're going to say if $0 square bracket 0 equals $1 square bracket 1. Then we are going to, or excuse me, $1 square bracket 0. This should be a 0. Then we're going to open up the brackets and we're going to return $0 square bracket 1 is greater than $1 square bracket 1. Boom, just like that. Then we come right here and we'll say else. We'll open up the brackets and we'll say return $0 square bracket 0 is less than, sorry y'all, less than $1 square bracket 0. Boom. Then we need to create our result or our output. So a place to store our output. So we come right here, come right here outside of the variable, and we are going to declare another variable called result, and we're just going to set that equal to 0. Then we're going to iterate over all possible left points. So we're going to say if I in 0 dot dot less than sign sorted x dot count minus 1, we're going to open up the brackets and we're going to create a max heap to track the y values that we've seen. So we're going to declare a variable, call it heap. We're going to set that equal to a heap less than, so a heap of integers, so less than, greater than, or less than, int, greater than, and put the parentheses outside. Then we're going to iterate over all possible right points where index j is greater than I. So we're going to say for j in I plus 1 dot dot less than sign sorted x dot count. We're going to open up the brackets. We're going to say let a equal sorted x square bracket I. And we're going to say let b equal sorted x square bracket j. Boom. Then we're going to come underneath that and get the current maximum y value that we've seen so far in the heap. By coming right here, we're going to say let max equal heap dot max question mark, because it's optional. Then we just say int dot min. Boom. Now we need to check if point B is valid relative to A. So if AY is greater than or equal to BY, this is going to ensure A is above or equal in the vertical position. Similarly, if BY is greater than max, then this is going to ensure that BY is strictly greater than any Y already processed for this I. So we're going to say, come underneath this, we're going to say if A square bracket 1 is greater than or equal to b square bracket 1 and two and signs, b square bracket 1 is greater than max, then we're going to open up the brackets and we found a valid pair, so we can say result plus equals 1, and we need to track this y value by saying heap dot insert, open up the parentheses, b square bracket 1. Now all we need to do is return the total count of valid pairs by coming right all the way down here, and all we have to do is say return result. Boom, y'all, that should be all she wrote. Let's give it a run. Make sure it runs correctly before we say, okay, we have an error. What does it say? Sorry, this should be not if, this should be 4. So 4i and 0. Sorry. Now let's run it. See if that works. Should do the trick, y'all. Let's see. And it's accepted. Let's go ahead and submit it. Make sure it's still accepted after we submit it. Let's see. Look at that, y'all. 214 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see. So with that being said, y'all, make sure you get one more look at the code. This is the top part. This right here is the bottom part. And yeah, y'all, with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.